Welcome to a lesson with Dr. Powell. We're going to look at an example of computing the acceleration function in terms of its tangential direction and its normal direction, and what goes here and what goes here. So to figure this out, as in the last video, we decided that this would be simply we take the length of the velocity curve and we take its derivative with respect to t. And that is exactly what goes there. What goes here is simply the length of the acceleration vector squared minus this length squared, using a Pythagorean theorem idea, since t and n are perpendicular to each other. So that's kind of the setup. And we're going to start with a position vector function. And let's just pick one. Let's just do something like t and 2t squared plus 1 and maybe minus 3 plus 2t or something like that. Okay, so let's just do this and see what we get. So first, the velocity vector is easy. We just take a derivative. We get 1 comma 4t comma 2. All right, then we find the length of this, because that's what this means right here, and then we take the derivative of that. The length of this is going to be the square root of 1 squared plus 4t quantity squared, which is 16t squared plus 4. In other words, it's the square root of 5 plus 16t squared. And that's, so this is the length of t is equal to this. All right, then we just got to take the derivative of that. Okay, so we could think of this as raised to the 1/2 power. So taking a derivative, it would become to the negative 1/2 power, but multiplying by a half on the outside. Using the chain rule, we multiply by the derivative of the inside, which is 32t. And I suppose we could rewrite this as 16t over the square root of 5 plus 16t squared. So this right here is actually the component in the tangential direction. Now, how do we get the component in the normal direction? We just use Pythagorean theorem. Here we need, but we need to know what the length in this direction is, or of the acceleration is, right, in here. So we have to kind of go, so we're going to have to figure that out. We're not quite ready. We have this part, we can just throw it in. We have to take a square of this. So that would be 16 squared t squared all over 5 plus 16t squared. And we're subtracting that off. But what we need is we need this now. Okay, so we need to go back and from the velocity vector right here, let's compute the acceleration vector. And we end up getting 0, comma, 4, comma, 0. All right. Now the length of this should be pretty clear. It's actually just 4. You could figure that out in various ways, but square root of 4 squared is just 4. So, so then we take that length and we square it. So we have a 16 minus that, and we're done. This right here is the acceleration in the direction of the curve itself as we travel. Or not in the direction of the curve, sorry. This is in the normal direction, sorry, in the normal direction. In the tangential direction, it's this, and in the normal direction, it's this right here. Thanks for watching.